welcome to our lesson on what we're going to call the extended product rule. So in a previous lesson we looked at the derivative of the product of two functions f and g, and we said that it was just the derivative of the first times the second plus the first times the derivative of the second. What we're going to look at with this extended product rule is what is the derivative of three functions, or the product of three functions. So let's say you had, how do we want to do? Let's call this big F. So this is our function is equal to three functions multiplied together. F at x times g at x times h at x. So how are we going to do the derivative of this? Well, all you really need to do is just treat it as two functions. Treat this as your first and this is your second, and then just use the regular power rule of two functions. So if I want to take the derivative, it's going to be the derivative of the first, which is this big thing, d by dx of f at x g at x times, you leave the second function, plus, now you leave the first function, and take the derivative of the second function. Alright, so now what is this? D by dx of f at x g at x. Well, that's, we had that written down up there, right? That's the product rule. It would be equal to this. So that would be equal, this is equal to, is this, so that's equal to that. So derivative of the first times leave the second plus leave the first times the derivative of the second. So that's this thing right here, right? Now we're multiplying that by h at x. Let's move over a bit. Down. Plus f at x g at x times h at x. Don't need the brackets there. Times h prime at x, sorry. And now I'll just expand this, okay? So d by dx of f at x, I'm using two different notations here, I just noticed. I'm using Leibniz, and then I've got our prime notation. Let's go to prime notation. So d by dx of f at x would be f prime at x g at x, and then we multiply that by the h at x over here. We'll expand into the bracket, plus f at x times the derivative of g of x, so that would be g prime at x h at x plus f at x g at x h prime at x. So that's the derivative of the three functions f, g, and h. It's these three terms. F prime times g times h, f times g prime times h, and f times g times h prime. So hopefully, you can kind of recognize sort of a pattern to the first one, and you maybe even could generalize it to what if there was four. What? Functions. So let's say big F was equal to f at x times g at x times h at x. Ooh, what letter now? I don't know. K at x. And you know what? I'll write it down and I'll leave it to you to prove it if you feel necessary. Hopefully you can recognize the pattern from here. It's going to be the derivative of the first one times, and then you leave the next 3 in this case. Plus, now you're going to leave the first one and take the derivative of the second one. And then leave the next 2. And then there'll be another term, which will be you'll take the derivative of the third one, but leave everything else. And then one more term where you just take the derivative of the last one. Okay, and then hopefully, you could probably even generalize to 5, 6, and on and on. Many functions. Okay, so just a simple example. We've got 1, 2, 3 functions here, and we want to find dy by dx. We've got one function, sorry, but it's a product of 3 smaller functions. So dy by dx. And if you're asking, could I just expand and then do the derivative? The answer would be yes. But we're just trying to illustrate the rule right here. So we'll take the derivative of the first one and then leave the next 2. Plus, leave the first one, take the derivative of the second one, and then leave the third one. And now, let's just move over a bit. Leave the first 2, and take the derivative of the last one. And now we'll multiply it out. So x to the 5. You know what? I'll pause it and I'll just do it. And you can do it on your own. Okay, so that's my expansion of all these brackets. Hopefully I didn't miss any terms. Just collect the x to the 5s. Yeah, I'll pause it again and do it. Okay, so there we go. That's all the like terms collected. So assuming I didn't make any mistakes, that would be your derivative of 3 functions. And yes, it probably would have been quicker to just expand first and then take the derivative. But we're just trying to illustrate a rule right now, and again, there will be examples where it won't just be polynomials, and you might need to actually apply the rule where you couldn't expand.